Hello all, welcome to the day 70 of the daily case study series for CBSE grade 12. The question goes like this. Sohan is confused in mathematics topic relations and equivalence relation. To clear his concepts on the topic, he took help from his elder brother. He has the following notes on the topic. There's a definition given on relation, and this relation becomes reflexive, symmetric, and transitive, provided these conditions are satisfied. The relation becomes reflexive if a comma a is in R for every a in A. The relation becomes symmetric if a1 comma a2 in R and if a2 comma a1 is also available in R for every a1 comma a2 in the set A. The relation R becomes transitive if a1 comma a2 and a2 comma a3 is in R, then a1 comma a3 is also in R. If a given relation is reflexive, symmetric and transitive, then it becomes equivalence relation. Question 1. Find the maximum number of equivalence relations on the set A equal to 1, 2, 3. The given set is A equal to 1, 2, 3. Let's frame the relations based on this set. R1 is to make it reflexive, symmetric and transitive. We can have these ordered pairs in the relation 1, 1, 2, 2, 3, 3. This is one relation. The second one, we can introduce these three ordered pairs and 1, 2, 2, 1. So that this becomes reflexive. 1, 2 is there and we see a 2, 1. So it becomes symmetric. 1, 2 and 2, 1 are there. So 1, 1 should also be there. It's also there. So it becomes transitive. R3 ordered pairs 1, 1, 2, 2, 3, 3 to make it reflexive. Apart from that, let's introduce 1, 3, 3, 1. 1, 3 is there. 3, 1 should also be there. It's there, so it is symmetric. 1, 3 and 3, 1 are there. So 1, 1 should be there. It is also there, so it is transitive. So R3 is another equivalence relation. R4 1, 1, 2, 2, 3, 3 and let's introduce 2, 3 and 3, 2. R4 is reflexive. For 2, 3, 3, 2 is there. So it becomes symmetric. For 2, 3 and 3, 2, 2, 2 has to be there and it is also there. So it becomes transitive. This is another equivalence relation. Next one is R5. 1, 1, 2, 2, 3, 3 to make it reflexive. And let's bring in all the other ordered pairs that we have put in R2, R3, R4. So this becomes another equivalence relation. So number of maximum equivalence relations is equal to 5. Question 2. Consider the non-empty set consisting of children in a family and a relation R defined as A R B. If A is a brother of B, then show that R is transitive but not symmetric. So the relation given in the question is A R B. The meaning of this is A is a brother of B. And we have to check if this is transitive and symmetric. When we say A R B, this implies that A is a brother of B. But B can either be a boy or a girl. We are not sure about that. Therefore, B is a brother of A need not be true. If B becomes a boy, then this is true. If B becomes a girl, this cannot be true. Therefore, B comma A does not exist in R. Therefore, R is not symmetric. Coming to transitive, for A comma B in R and B comma C in R, this implies that A is a brother of B, and when we say B comma C in R, this implies B is a brother of C. Analyzing the statements 1 and 2, we can come to a result that A is a brother of C, which implies A comma C is also in R. Therefore, R is transitive. Putting the results together for the relationship A or B, that is A is a brother of B, R is not symmetric but R is transitive. Question number 3. Show that relation defined by R1 equal to is a set of ordered pairs x comma y such that x square is equal to y square is an equivalence relation. The given relation is R1 is equal to x comma y such that x square is equal to y square. For A comma A in R, A square is equal to A square. Therefore, R1 is reflexive. For all A comma B in R, the meaning of this is A square is equal to B square. That is coming from the definition of the relation, which implies that B square is equal to A square. This implies that B comma A also exists in R. Therefore, R is symmetric. For all A comma B in R and B comma C in R, the meaning of saying A comma B in R is A square is equal to B square. Similarly, the meaning of saying B comma C in R is B square is equal to C square. Comparing the equations 1 and 2, we infer that A square is equal to C square, which implies that A comma C is also in R1. This implies that R1 is transitive. Putting the results together for the relation R1, R1 is symmetric and also transitive. Question number 4. Check whether the relation R x greater than y for all x comma y belongs to n is reflexive, symmetric or transitive. The given relation is R is equal to set of ordered pairs x comma y such that x is greater than y. Let's check whether this is reflexive. Considering 1 comma 1, 1 greater than 1 is false. Therefore, A comma A does not belong to R, which implies R is not reflexive. Now let's check whether it is symmetric. For A comma B in R, the meaning of this is A is greater than B, but B greater than A will become false, which implies that B comma A does not exist in R. Therefore, R is not symmetric. Now let's check if it is transitive. For A comma B in R and B comma C in R, the meaning of this is A is greater than B and B is greater than C. Comparing the results of 1 and 2, we infer that A is greater than C, which implies A comma C is in R. Therefore, R is transitive. Putting the results together, R is not reflexive, R is not symmetric, but R is transitive. If you found this video helpful, don't forget to like, share and subscribe to my channel Math with Meenakshi for more smart learning videos. See you all with another case study question tomorrow.